Hello class, I'm Betsy Alexander. Today I'm presenting an instrument evaluation on the measurement of children and adolescents' physical activity. The question I would like to investigate in my DMP project is for overweight and obese children and adolescents, what is the effect of physical activity and nutrition compared to no interventions to prevent or decrease obesity and comorbidities during the childhood years? On this slide, I'll give a brief overview of accelerometry. There's an instrument that measures accelerometry called the Actigraph GTX3. Accelerometry is an objective measurement of physical activity. The use of accelerometers to examine children's activity levels is valid. This tool shows active motion as well as times when the child is sedentary. The accelerometer is a small sensor device that detects motion. It's suitable to be worn continuously during physical activity and sleep. It should be worn on the non-dominant wrist, but may be worn on either. It may also be worn on the hip, trunk, and infants may wear it on the ankle to get a better and more accurate reading. Children with autism or sensory disorders may wear the device in a pocket of a form-fitted shirt. Accelerometry has been used for several decades, but it's grown in popularity over the last 20 years. A growing number of studies measuring physical activity in children have used accelerometry as a measurement tool. The rate of change in velocity is detected and measured by the accelerometer. Motion is detected through piezoelectric transmitters. Different models of accelerometers, such as uniaxial, biaxial, triaxial, and omniaxial, can measure acceleration in multiple planes of movement, but the real strength of this tool comes from its ability to measure the frequency, duration, intensity, and balance of physical activity with sensitivity. Progress of understanding this tool has been made, but consistency is lacking in its use throughout the research. On this slide, there's a little bit more information about the Actigraph company. It was founded in 2004, and the Actigraph was developed as an accelerometer device. Actigraph is considered to be a pioneer in the development of motion sensing wearable technology. Actigraph is based on intellectual property that had the original purpose to be used in the United States military. The collection of acceleration data has been used to develop algorithms to measure physical activity, mobility, and sleep. It has been used extensively in academic, pharmaceutical, and medical research. Actigraph's biosensor solutions have been used in clinical drug trials. It is considered the gold standard in measuring activity objectively due to its use in over 2,000 academic institutions, scientific organizations, and biopharma companies throughout 100 countries. The Actigraph is an objective level of measurement. The ability to quantify activity levels has improved drastically over the last 20 years by using accelerometers. Physical activity was historically measured by questionnaires or interviews that were prone to recall bias. Energy expenditure can be measured by indirect calorimetry. Energy expenditure can be expressed as oxygen consumption, carbon dioxide production, or METs, which is metabolic equivalents. A MET is determined by the amount of oxygen consumed while at rest. MET parameters are not consistently defined across studies. Physical activity and sedentary behavior can be monitored with accelerometers. Triaxial accelerometers, such as Actigraph, measure acceleration in 3 orthogonal axes. Microelectromechanical systems are used in efficient and cost-effective wearable devices for measuring exercise and sedentary behavior, but substantial variability exists in the method of use, placement on the body, and setting, such as being used at school or during sports. Some studies have shown that accuracy is greater when the device is worn on the hip rather than the wrist. Triaxial and omnidirectional accelerometers accurately measure physical activity and sedentary behavior. It can be used in observational and experimental research. On this slide, I'll discuss the evidence of reliability. Reliability is a psychometric characteristic. It is the consistency of the measurement. Internal consistency reliability is the consistency of an item's responses across a construct. Cronbach's alpha falls into this type of reliability. Test-retest reliability is the stability of a measure over time. Inter-rater reliability is the degree to which different observers give consistent ratings. Split half reliability is the results of one half of a measure are correlated with those from the second half. Item total reliability is the average correlation of a measure with the total score. For this slide on evidence of reliability, I'll present two studies that I found that measure the actigraph GT3X. First one is accelerometer data requirements for reliable estimation of habitual physical activity and sedentary time of children during the early years, a worked example following a stepped approach. This had an internal consistency of 0.524% sedentary time, 0.53% moderate to vigorous physical activity, and 0.52% for total physical activity. This wasn't a strong reliability score. More studies would need to be done. The sample size was young children that perhaps weren't as compliant with the study process. Some did not have the wear time that the study required. The Cronbach alpha would need to be a 0.7 to be stronger. Based on the Spearman-Brown prophecy formula, a minimum of 3 days was needed for consistent wear. 32% of participants met the minimum daily wear time of 360 minutes on 7 consecutive days. To reach 0.75, a period of 3 days were required for moderate or vigorous activity, and 4 days were required for a physical activity to reach a 0.8. The other study measuring reliability and validity of the actigraph GT3X accelerometer for children with cerebral palsy, a feasible study. And this study is not applicable to most of the population. Few children have CP. It was of interest to me because my 17-year-old has cerebral palsy. So there might be some bias with wanting to incorporate this study. But this one showed that there's excellent internal consistency reliability of the actigraph GT3X when it's placed on the hips. The ICC 0.96 to 0.99 with excellent reproducibility of the instrument. Well, for the hips on the child with CP, that's more stable. My own child, he's very spastic. His arms are in constant motion. So it would not be very accurate with a child with CP to have this on a wrist. The trunk would be the more sensible place to get more reliable measurements. On this slide, I will be presenting evidence of validity. Validity is also a psychometric characteristic. Validity is the accuracy of the measurement results. Construct validity is the extent to which the instrument measures the construct of interest. Content validity means the items measure the content that they were intended to measure. Criterion validity is the degree to which measure correlates with other measures of the same theoretical construct. Predictive validity is how well a measure predicts performance in the future. Discriminant validity is the degree to which the results of a measure do not correlate with those of other variables or measures. This slide presents some evidence of validity. The first article that I read about validity was a systemic review of the validity, reliability, and feasibility of measurement tools used to assess the physical activity and sedentary behavior of preschool-aged children. The actigraph GT3X demonstrated evidence of energy expenditure and oxygen consumption. Direct observation was used to determine convergent validity. The actigraph GT3X demonstrated good ability to determine sedentary behavior and vigorous physical activity. Accelerometers such as the actigraph, in particular the actigraph GT3X version, used in combination with proxy measurement tools, may be useful for a range of outcome measures, both intensity measure and contextual measures. So evidence suggests that the actigraph GT3X was able to determine energy expenditure and oxygen consumption. The actigraph devices have a good ability to determine sedentary behaviors as well as vigorous activity. As for the study done with children with cerebral palsy, they concluded with fair to good validity between the actigraph GT3X activity data and oxygen consumption. A feasible study that it concluded that accelerometers are reliable and valid devices to monitor walking for children with CP. This may be appropriate in rehabilitation and clinical practice research. It also demonstrated good retest reproducibility between two testing sessions. Actigraph GT3X right hip count data were used to evaluate concurrent validity. Fair to good validity was established between actigraph activity and oxygen consumption. Several research studies have used accelerometry, specifically the actigraph accelerometer, to measure physical activity in children and adolescents. This slide presents a few studies that have used the actigraph and accelerometry to determine the level of physical activity in school children and adolescents. Physical activity level measured by accelerometry and physical fitness of school children. Associations of accelerometer measures sedentary time, sedentary bouts, and physical activity with adiposity and fitness in children. Assessment of 24-hour physical behavior in children and adolescents via wearables. A systemic review of free living validation studies. Applicable to DMP project. The accelerometry appears to be an applicable instrument to use in my DMP project. Though not without its shortcomings, it offers the ability to generate valuable objective measurements to incorporate into the project. Research studies have demonstrated that it has validity in the measurement of physical activity and sedentary behaviors. And then for my last slides, I have references. Thank you all for your attention. I look forward to listening to your presentations as well.